All right, so we're going to take a look at the study guide. So this is vector components from initial to terminal points. Let vector v have the initial point at -1, -2, and a terminal point there. That's just a little mistake. Determine the components of vector v. Okay, so again, to determine the components, you need to combine the first ones. So the terminal minus the initial. Okay, so the terminal is this one. So 3 minus -1 is 3 plus 1, which is 4. And -4 minus -2 is -4 plus 2, which is -2. So again, just make sure, if I write it down, how about that? So this will be 3 minus -1. And then the second point will be -4 minus -2. And you could just use a calculator so that you don't get it wrong because of notation, because of, adding, subtracting. All right, number 2, add in vectors numerically. Okay, so you're given the two vectors, find the sum of adding the two, write the resulting component of. So we're going to add these two together. All right, so that's -6 plus 5. So again, we add in the first component, the first part of the component, then we add the second part of the component. So that's -4 plus 3. And again, put that in the calculator, and that will be our answer. So that's going to be -1 and -1. All right, adding vectors graphically. I think this is a little bit easier because you'll make less mistakes, but it's just a preference. So given the two vectors, find u plus v. So you first got to be able to plot it. So 2 and then 5, that's plotted. -7, -2, -7, -2, that's plotted. So this is the vector u, this is a vector v. Find the sum, so you're just adding these two vectors. So when you're adding these two vectors, you have two choices. You can translate this vector to this one or this one to this one. It has to go initial to terminal. Then you have to, again, do initial to terminal. So it can go in any direction as long as you're joining. You take your first one. So let me do this one. Let me do it in order. So u plus v. So this is my initial. This is my terminal, right? Then I join the next vector at the initial point at the terminal. So terminal and initial, they join together. So the initial part for v is this part right here, and I need to join it here. So I'm moving this vector up here. To move that vector up there, I can just count the boxes. So I have -7 to the left and -2 down. So I'm here, I'm moving this here. So I'm going to go -7 to the left and 2 down. And just to make sure that you've moved it correctly, it should have a parallelogram. Like you should see that distance between this is the same. Okay, so when I move that, I'm going to get my resultant vector. Okay, and write the resulting component form. So my resultant vector is from the very initial to the very end. So when you're adding even like multiple vectors, you just keep adding them, and then your very initial to wherever your very end is, that is your resultant vector, which is your answer. In component form, x is -5 and y is +3. So again, we're going to check this numerically, but that's how you do it graphically. So numerically, add in the two vectors. So you would have 2 plus -7 for the first one, and then 5 plus -2 for the second one. All right, so you'd get 2 minus 7, which is -5, and 5 plus -2, which will be +3. So you see, doing it numerically or graphically, you're going to end up in the same place. Graphically is definitely better when you have a lot, like when you have a lot like this, because you get confused with the negatives. So adding vectors cumulatively, okay, is you have a multiple vectors, you're told to add all 4 of them. The easiest way is to put them on top of each other, right? So you put the first one, the second one, third one, the fourth one. Put them on top of each other. So then you have all of these added together. So I can see this going to cancel with that. -7 plus 1 is -6. We have 7 here, we have 6, 7, so actually 7 minus 7 is 0, okay? So when I add all of these, I'm going to get -6, 0, okay? So all I'm going to do is move the graphs. Again, the order that you move this does not matter. So let me start with C. I'm going to start, my initial point is right here, I'm ending here. So I need another initial, so just like before, right? Initial terminal, then initial terminal. So another initial, let me take A. So I'll go left 1, down 2. So starting here, my initial for A is right here. Left 1, down 2. So this is now where A is. So A is gone, I can cross that out. Now I'm going to, and again, the order doesn't matter. I can take B, I can take D, I can take whatever. Matter of fact, let me take D. So I can all out of order. So again, the initial of D is going to join the terminal of A. So I'm going to go right 1, down 4. So starting at A, right 1, 1, 2, 3, 4, down 4. This is going to be my D. Okay, so that's D, so this is gone. All right, so I just have one more, which is B. So again, I'm going to take B and put it right there at D. This is going to be -7, -1. So -7, -1. So that's my B. All right, and then your answer, so you keep joining initial terminal to initial terminal, and your answer is your very beginning, which was here, right, to the very end. The last vector I drew was B. So the very end is right here. So it's this answer from the initial point to the very end. And that's going to be -6. And I don't go up or down, so that's going to be 0. So you see how we get the exact same answer whether you do it numerically or graphically. All right, let's multiply a vector by scalar. So now we've looked at adding graphically and algebraically. Now we're going to look at multiplication. Okay, so we're given this vector, and now we're going to multiply by -2.5, I'm sorry. Okay, graphically. So what does that mean? All right, well, anytime you have a negative, you're going to negate whatever your vector is. So my vector is -4, 2, -4, 2, so that's vector V, right? And now I'm going to multiply all of that by -2.5. So this is going to stretch by 2.5, but in the opposite direction. So let me first negate it, bring it to this side. So if I negate this, several ways I can do this. This is going to be, so think of it as reflecting over this way, right? So this is going to be -4, 2, so it's going to be +4, -2. I'm multiplied by -1, so to speak. So this is my new V, okay, by negative. Now I got to stretch that 2.5 times. So let me first make 2 of them. So that's 1, so it's 4 and 2. So 4 and 2. That's my second one. And then now I need 0.5. So instead of going 4 and 2, I'm going to do 0.5 of that. So I'm going to go 2 and 1. So that's half 1. Okay, so I'm multiplying this vector by -2.5. So I'm going to negate it, then multiply by 2.5, 2.5 of those. And then my final answer in component form will be 10 and -5. Okay, now we can definitely check this numerically as well, right? So I'm going to put it on the side here. So -4, 2, and we're multiplying that by -2.5. So all you do is you distribute it in -2.5 times 4, times -4, I'm sorry, is +10, and -2.5 times +2 is -5. So you can do it numerically or you could do it graphically. Okay. Number 6. Given this vector, determine the value of, so now we're doing not just multiplying, but addition and subtraction as well. And this is asking me numerically, right? Yeah, numerically. All right, so that's simple. So you have 3 times u. So I'm going to do 3 times whatever u is. U is -2 and 4, minus 5 times whatever v is. V is -2 and 1. Okay, now we're going to go ahead and just multiply it out. So 3 times -2 is -6. 3 times 4 is 12. So 3u is that. Then -5 times -2. Okay, so we can actually leave, shall we leave the minus outside? So we can do one of two things. Actually, I'll do both, just so in case you pick whichever one you want to do. So -5 times 2 is going to be +10. -5 times 1 is going to be -5. And because I distributed a negative, it's a plus out. Yeah, it's a plus outside. If you didn't want to distribute the negative, then you would get, and I'm just going to write it on the side right here, minus still outside, and we're distributing just the 5. So this would be -10 and 5. Okay, so now it'll be the first one, which is -6, 12. Okay, so whichever one your preference is, the answer is going to be the same. All right, in this case, we're adding the 2, so we're going to add this. -6 plus 10 is +4. And then 12 plus negative 5 is positive 7. Okay, and we're just going to double check to make sure that we get the same answer here. So negative 6 minus negative 10 is going to be negative 6 plus 10, which is positive 4. And then 12 minus 5 is 7. So whether you want to distribute the negative as well and make it an addition problem or just distribute the number, it is totally up to you. All right, combining scalar multiples of vectors graphically. Okay, so now we're going to do that graphically. All right, so given this vector, these two vectors determine 4v. So 4 of these minus u. Click and drag, copies, blah, blah. All right, so the vector u is 4, negative 3. 4, negative 3, that's vector u. V is 3, 2, that's vector v. Determine 4 times v. That means I need 4 of these. So this is 1. I need 4 of them. So it goes 3, 2, 3, 2, that's 2, 3, 2. So 1, 2, 3. I need one more, 3, 2. All right, so I have 4 of these now. All right, 1, 2, 3, 4. So that's 4v. All right, now I have a negative. Anytime I have a negative, what do I have to do? I have to negate it, right? So it flips over to the other side. So instead of it being 4, negative 3, it's going to be negative 4, positive 3. Okay, so this is now my new u. Okay, so you negate it, you got to flip it to the other side or multiply the components by negative 1. All right, so now I have u. How many u's do I need? Just 1. If I needed more u's, I would keep drawing however many u's I have. All right, once you have that, now you could either take this and move it here, or you could take this and move it here. It's a bit faster for me to take the shorter one, so I'm going to take this and move it here. Because remember, again, you have to have it going in order. So this is my origin. This is my end. Now I need my origin of this one to touch that one. So I'm going to move this there. So this is going to be 4 to the left, 3 up. So 4 to the left, 1, 2, 3, 4, 1, 2, 3 up. So all I did was move this here. Now, again, just remember to make sure that you did that correctly. It has to look like it's going to be a parallelogram, like that distance is the same all the way through. All right, so now that it's there, then my answer is my very beginning, which is right here, to my very end, which is right there. So this is my resulting vector right here. And that answer is going to be 8 and 11. Okay, so 8 and 11. All right, magnitude from initial and terminal points. Okay, so magnitude. What are we talking about when we're talking about magnitude? We're talking about this formula here, a squared plus b squared. Right. All right, so first you have to find the vector v so you can do a squared plus b squared. Because right now it's telling you the initial point and the final point, but I need to find the actual vector. So remember, to find the actual vector from initial point and terminal point, it's always terminal minus initial. So that's how you find the vector v. So let's do that. So my terminal point, so here's my terminal point, which is negative 3. So it's going to be negative 3 minus, and this got cut off, but negative 8. So negative 3 minus negative 8, and then negative 1 minus 5. Negative 1 minus 5. All right, so my vector v is equal to negative 3 plus 8, which is positive 5, and negative 1 minus 5 is negative 6. Now, this is my vector v, but I want to find the magnitude, right? So that magnitude of my vector v will be the square root of a squared, so 5 squared, plus the, sorry, I didn't say square root, b squared. So b squared is negative 6 squared. So this is the square root of 25 plus 36, which is going to give me 61. And you can simplify this, but in the answer, they don't want you to simplify, so that would be your actual final answer. Okay. Number 9, find the vector magnitude and direction. Okay, so now we're still finding the vector and the magnitude, but in addition to doing these two, we're also finding the direction. So let's go ahead and get started. So you have an initial point at, oh, and this is graphically. Oh, this is great. Okay, let's do it graphically. You have an initial point of 3, negative 2. My initial point is 3, negative 2. That's my start. my terminal point where my arrow is -3, -4. So here's my arrow point. So this is my vector v. Okay, plot vector v. Boom. Move the vector so that the tail is at the origin. So I'm going to move this vector to the origin. And I need it to be, in terms of x, I need it to be 3 plus 3 is 6 and -2. All right, so I need it to go -6, -2. So all I did was move vector v to the origin. It is 6 units to the left and 2 down from the origin, 6 and 2. All right, now that we have that, it says find the component form. Okay, so the component form is -6, -2. All right, so it's actually really easy to do it graphically. All right, then the magnitude is, remember, the square root of a squared, which is -6 squared, plus -2 squared. And putting that in the calculator, that's 36 plus 4 is the square root of 40. And they don't want you to simplify it, so you're just going to put the square root of 40 in there. And then the last thing is to find the direction. Now remember, direction is the inverse tan of b over a. So that means the inverse tan of b, which is -2. Oh, actually, sorry, just 2. You don't need the negative. Over a, which is 6. All right. Putting that in the calculator, you're going to get 18 degrees. Make sure you are in degree mode. So hit the, the settings tab and then hit degree mode. Find vector magnitude and direction. Okay, so find vector magnitude and direction. It's just given to you in a different format. So this one was given to you as initial and terminal point as a vector v. This one is given to you in polar form. All right, so find vector magnitude and direction. So given u is equal to that, v is equal to that, find the sum. All right, so before I can combine them, I do first need to multiply these out. So go ahead and distribute that 5 in. So my vector v is really equal to, and I'm just going to leave this as exact so that I don't have to worry about all these decimals. 5 sine 160 and vector, oh, that's vector u. I'm sorry, that's vector u. Vector v, go ahead and multiply this 3 in. Vector v is 3 cosine 190 and 3 sine 190. Okay, now we're finding the sum, so we're going to add them. So we're going to add these two. So when I add this and add this, and again, I'm just going to leave it in exact format so that I don't have to round. So what I'm going to do is I'm going to write u plus v is equal to 5 cosine 160, and we're going to add it to 3 cosine 190. And we're going to do the same thing with the y's. All right, so 5 sine 160, 5 sine 160 plus 3 sine 190, sorry. All right, so that's my u plus v. So find the sum and write your answer magnitude and direction form. Okay, because this is u plus v, this is in vector form. So to find the magnitude, all right, remember the magnitude is the square root of a squared plus b squared, right? So you have to take this first one and square it, and this second one and square it, and then take the square root. All right, so that's going to be the square root of, now I'm going to put this whole thing in the calculator. So it's going to be roughly, and again, don't round until the very end, 7.65288864. And again, make sure that your calculator is in degree mode, minus this whole thing in the calculator squared. So that's going to be roughly 1.1891562 squared. So put this whole thing in the calculator, and you're going to get approximately 7.7. So the magnitude is 7.7, and we know that outside is the magnitude, 7.7. Now we need to find out what theta is, right? So remember, that is equal to the inverse tan of b over a, right? So the inverse tan of b, so again, b is this whole thing right here. All right, so 5 sine 160 plus 3 sine 190 divided by A, which is this whole part right here. So that's going to be 5 cosine 160 plus 3 cosine 190. Or rather, this part right here is going to give me, B is this one, right? Because that's B, and then this is A. All right, so again, I'm putting it exactly in the calculator so that I don't get the rounding off. And that's going to give me roughly about 9. Okay, now we know that this U plus V, all right, because these are, so this one, this one's negative and this one is positive, right? So if I was to draw that, X would be negative and Y would be positive, it would be somewhere in here, right? Which means that this 9 is the reference angle right there. So this is 9. But that's not the answer they're asking for. They're really asking you, what is this? So what do I have to do to that 9? I have to subtract it. So it'll be, this whole thing would be 180 minus the reference angle of 9, which would give me 171. So my angle is 171. All right, subtracting vectors graphically, and I really should have put this in the front, but it's okay. So given these two vectors, so 1, 3, 1, 3, that's U. Negative 8, negative 7, that's V. Find the difference, U minus V. So again, we've done this prior, so you start off with U. So there's my U, minus V. Now remember, minus V, anytime you have a negative, you're going to negate it, right? So it's going to flip over. So this is negative 8, negative 7. If I multiply negative 8 by negative 1, you're going to get positive 8. Negative 7 times negative 1 will give me positive 7. So when I flip it over, it's going to go 8, 7. So this is my negative V. So I've negated this. Can you think of it as flipping it over this way or multiplying both coordinates by negative? All right, now that I have that, remember to add. So U minus V is the same as U plus negative V, because that's what I did. I negated it, right? So now I'm adding these two. So I either move this to here or I move this to here. All right, it's probably easier to move the shorter one, so I'm going to move U here. So remember, my initial to terminal, and then it has to go initial again. So what's the initial of U? And then to the final of the terminal of U. So it's going to be 1, 3. So initial of U right here, and then it's going to go right 1, up 3. So I just moved my U. And again, remember, you want to make sure that it looks like kind of the same on both sides, right? Or you can think 3, 1, 3, 1. Okay, so that's perfect. Then your resulted vector is your very beginning to your very end. So that's going to be 9 and 10. So your answer is 9 and 10. Now it says do this 2 different ways. Okay, so the first way is boom, right? The second way is instead of me moving anything, U minus V is going to be the same as me saying if I start at the terminal of V, start at the terminal of the second one and go right to U. If I do that, that will be the same as saying U minus V. If I don't start at U, but I start at the second and then go to the first. So that's going to be in the X direction, that's going to be 8 plus 1 is 9. So I still get 9 as my X. And then up, negative 7, that's 7 plus 3 is 10. So once again, maybe a faster way of doing this. If you only have 2, you can do that. You can either negate it and move, or you can start at the second one and go to the first one. All right, so we're going to take a look at plotting complex numbers. All right, to plot the complex number 4 minus 6i, it's just like you plot x and y. This is your real axis. This is your imaginary axis. All right, so this is your real number is 4, so I'm going to go 4. And then this is your imaginary number. It has an I, negative 6. I'm going to go 4. And then on my imaginary, I'm going to go negative 6. And that's my point. Okay, so 4, negative 6. So real, imaginary. Real is x-axis, and imaginary is y-axis. All right. taking a look at rectangular to polar form. So we're just going to do a conversion. So to do a conversion, remember polar form, you need to have r cosine theta plus I sine theta. This is what it needs to look like. So I need to find r. Okay, so to find r, first let's go ahead and plot roughly where this is. So it's -6 this way, and then up 9. So it's going to be quadrant 2. So -6 up 9 somewhere over here. Okay, so this is -6 and this is 9. All right, so again, you plot it. And then you need to find r, which is the absolute value, this length right here. All right, so we can do this one of two ways. So draw a triangle, doesn't matter if I draw it this way or this way. What's the distance from here to here? This is going to be 6. The distance from here to here, this distance is going to be 9. So how do I find the rest? It's the square root of 6 squared plus 9 squared, which is equal to the square root of 36 plus 81, which is the square root of 117. And they don't want you to simplify it anymore, so that's that. So this is the square root of 117. And then the only thing I need to find is theta, right? So I need to find this right here. So theta is going to be equal to the inverse tan of b over a, right? So you'll remember b over a, or you can say imaginary over real. Okay, so that's what it is. So theta is the inverse tan of the imaginary number, which is 9. And again, you can just ignore the signs over the real, which is 6, because we're going to need to calculate what quadrant it is in. And since it's to the nearest 10th, that means one number after the decimal. So it's 56.3099. One number after the decimal, that's this. This 0 is not going to do anything. So theta is equal to 56, approximately 56.3. Now, that's not my answer that goes in here, because this is this right here, right? It's always my reference angle. Reference angle is the shortest distance from the x-axis to the line that you're looking for. So this right here, let me just make this a little bit clearer. This is what I just found. That's my reference angle. So I need to find what my angle is from the positive x-axis to the line. So what am I going to do? This whole thing is 180, and I'm going to subtract my reference angle. So it's going to be 180 minus 56.3, which is going to give me 123.7. And that's going to be my answer, 123.7. All right, looking at polar form. So now this time you're given to it in polar form. So remember, polar form is r cosine theta plus I sine theta. You're given in that form. You're given in this form, and you need to make it back into this form. All right, so to do that, all right, we are going to go ahead and distribute what is the r distributed inside. So this is going to be 2 radical 2 cosine 225 plus I, or 2 radical 2i, 2 radical 2i sine 225. Okay, now if you look at the unit circle and find out what cosine of 225 is, and remember the unit circle, x is cosine and y is sine, which means the first one is cosine and the second one is sine. So just be careful. If you look at the unit circle, you're going to get cosine of 225 is negative radical 2 over 2. And sine of 225 is also negative 2 over 2. Okay, so substituting the exact values for those using the unit circle. Outside I have 2 radical 2 here plus 2 radical 2i. Okay, so we're just going to go ahead and simplify this. So we're going to multiply this out. So when you're multiplying, I'm going to rewrite this so that I can show you. So what I'm going to do is just put it over one denominator. Whenever you're multiplying the numerators and multiplying the denominator. So I'm going to multiply the numerators out here. So it's going to be negative 2, and then I have radical 2 times radical 2, which is going to give me radical 4, or you can know the radical times a radical, and if the same number, it's just 2. So I'm not sure what your understanding is on that. Then on the bottom, I have 1 times 2, which is 2. Okay, over here, positive and negative is going to be a negative. And then I have the same thing going on. So on the top, radical 2 times radical 2 is going to be radical 4, or you already know it's 2, doesn't matter. And then there's a 2i out here. And on the bottom is 1 times 2, so that's 2. All right, let's go ahead and simplify this. Radical, first of all, if it's on the top and bottom, those cross out. Radical 4, square root of 4 is 2, so it's going to be minus 2 minus. And here, again, square root of 4 is also 2, so minus 2i. So going from polar form into complex, and this is how you go from complex into polar form. Okay, number 15, plotting polar points level. You don't need to show any work because you either know how to plot it or you don't. So because this is polar, remember polar has to do with, let me go to here. Polar has to do with r, right, and direction. Okay, so the radius and direction, and that's really what it is. So these circles here, these are the radius. So that's that one. That's that one. So that's the R. And then direction is what you're used to. So 0, 30, 45, 60, 90, 120, and so forth, right? You know what those are. So that's direction. So this is your R, and this is your direction or your theta. This gives you the direction. So I'm going to go negative pi over 4. Well, you need to know where pi over 4 is. So pi over 4 is 45 degrees, right? So that's the second line. This is pi over 4 normally, right? But you got to go negative. So it's the second line in the other direction. So positive is this way, negative is this way. So I'm going to go negative pi over 4. So that's 2 to this line right here. And then this R is, so it's on this line, and then it's 1, 2, but in the negative direction. So I'm going to keep tracing this and go 1, 2. So this is my point right here. Okay, so you just got to keep this in mind. If you're doing theta, this is positive, right? And this is negative. And then if when you're doing the R, it's the actual circles. The positive ones will stay wherever your theta is. Negative ones will be in the opposite direction. All right. Simplify this expression. Okay, so this is adding and subtracting complex numbers. This time we're subtracting. So remember, you got to distribute the negative just like you would if you were doing polynomials or something like that. So this is 2 minus 7i. Negative times a negative is a positive 2. A negative times a positive is a negative 6i. All right, let's combine what we know. So we got 2 plus 2, which will be 4. And then we got negative 7i minus 6i, which will be negative 13i. And that's really all that you have to do there. All right, number 17, again, just like you're kind of used to doing with polynomials, you're going to multiply these out. You can do the box method, you can do the FOIL method. I mean, there's so many methods you can do it in. I'm going to do the box method because that's just the simplest for me. So I'm going to put negative 6, negative 9i on the top, and on the bottom, I'm going to put negative 11 and 7i. And then I'm going to draw a box, okay? 11 times negative 6 is, negative 11 times negative 6, I'm sorry, is positive 66. Negative 11 times negative 9i is going to be positive 99i. 7i multiplied by negative 6 is negative 42i. And then 7i times negative 9i is negative 63i squared. And what do we know about I squared already? It's going to equal to negative 1, right? So let's go ahead and combine. So I have 66. This combined 99 minus 42 would be 57. So plus 57i. And then this is going to be negative 1, which is just going to change this from a negative to a positive, so that would be positive 63. And you can see that you have these two that you can combine, so that would be 66 plus 63 is 129 plus 57i. And you just want to make sure you have the number and then the imaginary number. Okay. And then finally, you're going to divide complex numbers. All right, so remember to divide, we want to multiply top and bottom by the conjugate. So that's 10 plus 9i, 10 plus 9i, 10 plus 9i. And what's going to happen is you're going to get rid of the i's on the bottom, essentially. So again, we're going to multiply this. I'm going to stick to this box method. I'm trying to think where to do it. Let me do it right here. So I have this times this, and this times this. Okay, so the top multiply together and the bottom multiply together. So on the top, I have negative 28 minus 11i. On the side, I have 10 plus 9i. All right, and I'm just going to multiply those out. So this will be negative 280. This times this. This times this will be negative 110i. This times this, 9 times 28, will be negative 252i. And then this times this will be negative 99i squared. Now again, remember I squared is equal to negative 1. All it does is changes that sign. So when we combine this, you're going to have negative 280. Combine this two, so negative 110 minus 252. I'm going to get negative 362i. And then this is just going to change that sign, plus 99. Combining these two, on the top now, it's going to simplify to negative 280 plus 99 is negative 181 minus 362i. All right, on the bottom, I have a difference of squares, and anytime I have a difference of squares, like the same numbers minus and plus, I know I squared the first one, so that would be 100. And because it's a difference of squared, this is minus, and then you square the second one, so that would be 81i squared. Well, again, what do I know about I squared? It's equal to negative 1, right? So this is going to be, let's do negative 181 minus 362i all over, and we got, all this is going to do is change the sign. So it's going to be plus 81. So you're going to have 100 plus 81, which is 181. And that's really what all you can do except for simplifying. So let's go ahead and simplify. So I can write this as two separate fractions. Like I can do this, negative 181 over 181 minus 362i over 181, because I need to simplify. This is going to go one time, so this is negative 1 minus 362 divided by 181 is equal to 2. So minus 2i. So always just be careful to check if you can simplify there at the end. You can write them as two separate fractions and simplify them individually. All right, so that's pretty much all it is. All right, so which type of conic section does each of these equations represent? Because remember, you can get any one of these 4 questions. Okay, so remember, a circle has the same coefficients. Now, it's very important I write coefficients because sometimes there could be a fraction here, okay? So I just want to say it has the same coefficient. So the x squared one has the same coefficient as the y squared. In this case, an invisible one. All right, so this is a circle. So same coefficient where this is your center and your radius squared. All right, when you see the ones with the fractions and both terms are squared and it is a plus sign, that is an ellipse. Okay. If you see both of them are squared and it is a minus, okay, and keep in mind that minus could also be over here and this is a plus, so just look for the minus. All right, if it's a minus, it is hyperbola. All right, and then finally, if only one of them is squared, so in this case, only this one is squared, then it is a parabola. So again, if both of them are squared, okay, it's one of these 3 options. Parabola is the only one where only one of them is squared. Then once you know all of them are squared, you're looking for, okay, let's do, if you have a minus, it's a hyperbola, then now you have these 2 options. And then here, if the coefficients are the same, it is a circle. If the coefficients are different, meaning this is 1 over 9 and this is 1 over 49, then it is an ellipse. All right, identifying conics as well. Now this time you're given an equation, the same exact thing we just went through here, right? So if it is a circle, both of them are squared, both of them are squared. Or let's start off with the easiest one. If one is squared, it's a parabola. This is the only one that has one thing squared, right? Because this has two, this has two, this has two. So this is a parabola. All right. If they're, and I'll do it in the same order I did it. If both terms are squared and there's a subtraction sign, it is a hyperbola. If both of them are squared and they're addition, okay, then you have to look at the coefficients. So here there's an invisible one, here there's an invisible one. If the coefficients are the same, then it is a circle. If the coefficients are different, then it is an ellipse. So just really, really simple, a quick way of just telling which kind of conic it is. All right, now you know what kind of conic it is, and now convert it to look like the equation that belongs to that conic. So which type of conic is represented in this equation? So again, these has 2 squared and it has a negative, so this is a hyperbola. Okay, this is another example. What does this have? This was only one squared term, so this is a parabola. Now, the reason why it's very important to identify which one it is because the equation is going to look a certain way, right? So on the bottom of a hyperbola, I'm going to go ahead and start off what it should look like. So it's something squared minus something squared equals 1 over something something, right? If it's a parabola, what I'm looking for is something squared, right, equals, and remember here you're going to have that 4p, so you're going to have some number out here, and then another parentheses with either x or y minus another number. So I have a general idea of what the equation should look like. So when I finish doing this, I'm trying to set it up to look something like this, right? So starting off with a hyperbola, I'm going to go ahead and complete the square. So again, we're going to start off with the x squared just because it's first. So take out negative 25. And I'm going to leave a little bit of space above just so that I can do my 3-step process. So I'm going to underline it to make sure I know I've used that, right? So that's going to be x squared, right? So I'm going to find the other x, which is this one. And I'm taking out negative 25, which means I'm dividing by negative 25. So 100 divided by negative 25 is going to give me negative 4x. Leave a space. So that's my x version, right? Now I'm going to do my y. So same thing on my y. So take out 4. So now I have a y. And then I find the other y, and I've taken out 4 here. So it's going to be 24 divided by 4. Okay, and that's going to leave 6y, leave a space, equals, and what we're going to do to this last one that I did not underline is we're just going to take it to the other side. So it's going to change from a negative to a positive. Okay, so that's my setup. My next line, I'm going to leave a little space, write the exact same thing, only here it's going to be x squared. Write the exact same thing here. It's going to be y squared equals, and leave that blank. All right, so I've set it up for my 3-step process, and that's really what I was trying to do. I want to see these arrows. You don't put these arrows, you're going to make mistakes. So if I do them, you do them. I want to see an arrow that does that. What do I want you to do? Divide by 2. Step 1, so that's negative 2. Then what do you do after that? You square it. Go ahead and write it in because you're not going to make a mistake if you do this. Plus 4. Last step, multiply, and apply to the other side. So negative 25 times 4 is negative 100. So apply it to the other side immediately. All right, we're going to do the same thing over here. So 3-step process. Step 1, divide by 2. Step 2, square it. Step 3, multiply and apply to the other side. So 4 times 9 is 36. So that's going to be applied to the other side. All right, let's go ahead. This is already written out for you. Go ahead and combine this. So 164 minus 100 is 64 plus 36 is 100. All right, boom. Okay, so we're almost there. So remember, I want it to look like this, right? So I needed to have a 1. So that means that I need to get rid of this 100 somehow. How can I get rid of this 100? I can divide every single thing by 100. Once I divide everything by 100, so this fraction right here is going to simplify. It's going to, and look at this. This simplifies to a negative, right? So this is negative x minus 2 squared over, and this simplifies, 25 goes into that 4 times and into 25 one time, so 4 over here, plus 4 over 100, so 4 goes into 4 one time and into 125 times. And then over here, I'm going to have y plus 3 squared equals 1. So I'm almost there because it has to look as something minus something. So I need to just switch these two around. So I'm going to write this one first, y plus 3 over 25 squared. And then this one second because it has the minus sign, x minus 2 squared over 4. Now I have my equation for my hyperbola in general form. Okay, now I'm going to repeat the same thing, same but different, for the parabola. Okay, so again, we want to end up here. So I'm always keeping my end in mind because I want to do things to get to my end, right? So first thing first, what are these fractions? I know you hate fractions. So let's go ahead and get rid of them. To get rid of the fractions, going to multiply by the largest denominator. The largest denominator in this case is an 8. And if that doesn't get rid of them, you just multiply by whatever denominator is still left. Okay, so in this case, I'm going to get 8y equals, this crosses out with that, so negative x squared. 8 divided by 4 is 2 times 3 is 6. And if you don't know what I'm doing, that's okay. Go ahead and put that in the calculator. 8 times 3/4, okay? This 8 cancels with this 8. If you just know mathematically your steps, it can make it faster than a calculator. But by all means, if you don't know, you're just going to do 8 times in a calculator, 41 over 8, okay? All right, boom, this looks like this. I need it to be squared term on the left. So what am I going to start doing? I'm going to start moving the squared term to the left. Now, I don't want to I'll just go ahead and do it. All right, so I'm going to move this to the left. I'm also going to move the x to the left, and which means everything else that's not attached to the x is going to go to the right, and this needs to go to the right. All right, so that's the plan. So let me go ahead and do it. So if I move negative x squared to the other side, it changes to x squared. If I move positive 6x to the other side, it changes to negative 6x. Then if I move 8y to the other side, it changes to negative 8y. And this is already on this side, so it stays as negative 41. All right, so we're going to go ahead and complete the square here. So we're going to set it up. So there's nothing to take out, so I'm just going to write it. So x minus 6x, leave a space, equals, and then what we have on the other side, x squared. All right, then leave a little bit of space for my 3-step process. Going to be x squared equals, and I'm going to write the negative y because that's not going to change. The only thing that's going to change is that number because of my 3rd step. All right, so let's go ahead and do the 3-step process. And again, I want to see these arrows. Divide by 2, step 1. Square it, step 2. Multiply, even though there's an invisible one here, you still go through that step. Multiply and apply to the other side. So I'm applying 1 times 9, which is 9, to the other side. Okay. Go ahead and combine your like terms. So negative 41 plus 9, again, put it in the calculator, negative 32. All right, so it's starting to look like this, right? So I'm good here. I know there should be some number here because it's 4 times p outside, right? So I know there should be some number here. So here I already have it set up. I'm okay there. So I know there should be some number here, but I also know that the variable in here is by itself. And right now it's not by itself. So what I'm going to do is I'm going to factor out negative 8. So still over here, negative 3 squared equals negative 8. I take it out. So remember, taking it out is just dividing by it, right? So I'm dividing both of these terms by negative 8. So I'm going to get y. Negative 32 divided by negative 8. And once again, use a calculator. It's going to be positive 4. All right, perfect. That looks like what I'm looking for, right? So I write negative 8y plus 4. Keeping in mind that this is 4 times p. So p is 2 and it's negative, and since x is squared, it's n. All right, so that's just how you pull the information, but you don't need that for this question. So it doesn't matter what they give you, and I'm not going to do 4 examples on every question moving forward. The process is exactly the same. Start off with what the formula should look like at the end so that you have it written down. All right, then complete the square in order to get there. All right, the next one, graphing is all about understanding how to pull information, okay? So this right here is a circle, okay? So I'm actually going to go ahead and go through them and just identify what it is. So I know that this is what it should look like. So this is a circle. How do I know that? Because both terms are squared with a plus and the coefficients are the same, circle. All right, this one is a So it's a plus sign there. So this one's an ellipse. How do I know that? Both terms are squared and the coefficients are different. Okay, so if this had a 16 as well, it would actually be a circle, even though it's a fraction. So this one's an ellipse. Okay, so I'm just identifying it so that I can graph it a little bit faster. All right, both terms are squared, but we have a what? A minus, so this is a hyperbola. All right, what about this one? We only have one term squared, so this one is a parabola. Okay, now I've identified it. It's just a matter of pulling out the information. All right, so the circle, pull out the center. So the center is, find my x first. Here's my x. So this is opposite. So it's -9. Find my y, opposite, -1. So my center is at -9, -1. Boom, nice and easy. All right, according to the equation of a circle, this is the radius squared, right? So radius is going to be the square root of that. It just happens to be 1, which is 1. So that means I'm just going to go a distance of 1 in all directions, and that will be my circle. Nice and simple, okay? Most of every question you pull in the center or the vertex, which is pulled out in the same way. So it's a matter of being able to identify what the question actually looks like. All right, so we're going to go on to an ellipse, okay? So I am going to teach both the ellipse and the hyperbola in the same way because they're very similar, and I want you to understand the difference, okay? So the difference between an ellipse and a hyperbola, okay? So when we go into an ellipse, again, same thing. Let's pull out the center. So let's pull out the center in all of them. So the center the center in your ellipse is going to be, again, find my x, find my y. So x is opposite, -3. Opposite of y is +3. Okay, so that's my center. And I'm actually just going to find the center of all of them just so that this is faster. This is my center. Okay, so again, find my x. It's on this side. There's nothing there, so nothing in math is 0. Y is opposite, so that's going to be -3. The parabola, this is no longer called the center, but it's called the vertex. Okay, so again, find my vertex. This one, opposite in parentheses, that's going to be +3, and that's x. So I find x first and then y. There's nothing with y, like, because it usually would be in parentheses, right? So this is technically like a +0. All right, so that's 0. All right, so same idea in finding the center or the vertex for all of them. But I really want to pay close attention to my A's and my B's for both the ellipse and the center. So let me go ahead and really emphasize this out for you, okay? When you're looking at the ellipse, your A squared is your longest side. So I'm just going to write that somewhere. A squared, oh, that's not squared. A squared is longest. Okay, so wherever your A squared is, so your A squared can interchange between the fractions. And here we're just going to have an invisible 1 fraction. So find my A squared. That is my longest side. That is the distance. And that's also the distance to the vertices. Excuse my writing. Vertices. All right, so find my longest side. So which side is longer? It could be on this side or on this side. But in this case, this side is longer. And remember, this is always squared. So A is equal to 4, which means the other one is B. So B is equal to 1. So you just square root them and you'll find the actual original ones. All right, so I know my center is -3, 3. That's my center. My ellipse could be either horizontal or vertical. And your longest side is what tells you that. Okay, so also tells you direction. All right, I'm just making these notes so that you can really understand the difference. All right, so my A squared is 4, and this is attached to what letter? To the X. So I'm going to go in the X direction 4, and this is going to be my longest side. 1, 2, 3, 4 on either side. 1, 2, 3, 4. This is the distance from the center to the vertice because A is with the vertice. All right, then my B is 1. So you start at the center, you go up B, 1. Okay, and this is attached to what letter? Y. That's why I'm going up or down. All right, so this is an ellipse that looks like this. It is stretched horizontally. Okay, now let's look at the difference between the ellipse and the hyperbola. So once again, this is about the A squared being with the longest side. In the hyperbola, A squared is no longer the longest side. It could actually be the shorter side, but what it is A squared is always first. A squared is always first. Okay, so very, very important that you understand the difference, because a squared is always on the left, and it could be the longest or the shortest side. It doesn't matter. A squared is always, always, always first. All right, and the other thing to know about a squared is that whether it's horizontal or vertical doesn't matter. A is the distance from the center to the vertex. So this will be the vertice, okay? A is the distance from the center to the vertex. So that will be your vertice. Very important when you're actually answering the questions to know that difference. So I'm also going to write that there. A is always first, and A is distance from center to vertex or vertices, and is vertices. All right, so A is the distance from your center to your vertex, and it's what is your vertices. So B is going to be your co-vertices, okay? So that and that is very important. The last thing that you need to know is now, because, oh, how do I know the direction, Miss Ainley? Because a squared was telling me the direction here. It's horizontal, right? However, a squared is not about direction anymore in a hyperbola. So what is direction? Direction has to do with the negative. So the negative is direction, and is opposite. Okay, direction is opposite. So here I can see a couple of things. First, A is always first, so I'm just going to write some information. A is equal to 5, B is equal to 2, because we're taking the square root, right? The negative is attached to the Y, so I think this is vertical, because it's the Y, but it's really opposite, so this is horizontal. So I'm just going to write all the information down just so that I'm on the same page. Horizontal. All right, finally, I also need to know, since A is 5, which way I'm going. And that is attached to X. So this is in the X direction. And 4, which is B, is attached to Y. So this is in the Y direction. All right, so I start off with my center. So let's go ahead and draw it. I start off with my center, which is 0, -3. Okay, 0, -3. All right, I know that this is horizontal, meaning it's going to open up like this and like this, okay? A is 5 in which direction? 5, in X, sorry. So I'm going to count 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so this is the distance, remember, from the center to the vertex. So really, the thing is going like this, okay? But I won't draw it at this very, very second. All right, B is 2. So B is 2, and it's in the Y direction. I'm going to go 2 up and 2 down. With a hyperbola, you want to make that box, and that box goes from each corner of your vertices and your co-vertices. Okay, the reason you do that is because now you can draw your isotopes. So my isotopes goes through the corner and the center. So it looks like that. And looks like that. Now, the reason I waited to draw my hyperbola is because it can never touch that, right? So the vertex, again, was right here. All right, that's the vertex. And it goes this way, never touching the isotopes. So it goes this way, never touching the isotopes. Okay, that's your hyperbola. So again, it's horizontal. A is 5. So this right here, the distance from the center to the vertex is 5. B is 2. Okay, so again, major difference. Here, a squared can be either here or here. Here, a squared must always be first. Okay, so that's the biggest difference between that and the ellipse. The hyperbola is a little bit easier. Once you need 3 things to graph it. You need the vertex, you need direction, and you need what P is. And remember, this right here is 4 times P. Direction tells you X is squared, okay? So if X is squared, it's either going to be, so direction-wise, it's going to be up or down. Because this is negative, it tells me, because P is negative, so this is 4 times 3 would give me 12, right? So P is equal to 3, and it's negative, so that means it's actually doing this. Now, notice I don't put the negative with the 3 because technically it's not like you're saying P is -3. You're just saying the negative indicates that it goes down. So let's go ahead and graph this so we can see what it looks like. Vertex is 3, 0, so 3, 0, this is my vertex. P, and again, you do need to have what it looks like. So you understand the difference? So the distance from my vertex to the directrix is P. The distance from my vertex to my focus is also P. And very important to know your focal diameter. Your focal diameter is touching the parabola on both sides through the focus, and each of those sides is 2P, or total distance of 4P. In other words, this number here represents the total distance. All right, knowing that, we're going to come back and draw it. So if I go 3, so I know it goes down, right? So my focal point is right there. So 1, 2, 3. This is my focus. That means my focal diameter will go this way. Do I know how much? I do, because it's 2P on either side. So if P is 3, 2P on either side is 6. So 1, 2, 3, 4, 5, 6. And then 6 on this side. 1, 2, 3, 4, 5, 6. Okay, so this is my focal diameter right here through my focus. 2P on each side, a total distance of 4P. So in other words, if I really count this, it's 12 boxes in total. All right, so this is what it's going to do. Oops, I missed it, but make sure it goes through there, okay? That's what it's going to do. That's my focal diameter. This is my focus. That's my center, and I didn't have any space for it, but my directrix is 3 up here somewhere, and I don't want to be untidy, but we're going to have to be, so I give you a visual. Let me do it in pencil. This right here is my directrix. Now, very, very important for you to understand how to write this line. So I'm just going to do it here because it's in another question, but that's graphed, right? This line goes through which axis? It goes through the y-axis. So this line is y equals. And the point that it goes through this axis is 3 above this number here, right? So this one was 0, so 3 above that is 3. So it goes over 3. If I needed my, what is it called? My line of symmetry right here. Think about what axis is it going through? It's going through the x-axis, so this is x equals. And what number did it go through? 3. Okay, so that's how you talk about these lines. Anytime you have a line, it has to be y equals or x equals. It's just whatever line it goes through, what axis it goes through, I'm sorry. All right, so we are going to write equations given the actual graph. So again, I'll do these two together so you can really understand the difference between the ellipse and the hyperbola, and these two can be done separate. It seems from all 4, I'm actually going to do them all at the same time. From all 4, you can always grab the center. So let me grab the center. This is -5, -1. All right, from this one, the center is -4, -1. From this one, the center, the absolute middle is 1, -4. All right, and for the parabola, I'm sorry. This is not the center, but it's like the center. This is the vertex, and that vertex is 2, -1. All right, so very similar in how you start the problem. No matter which problem you get, you need the center. You need HK, right? No matter what it is. All right, if it is a circle, nice and simple. The only 2 things I need to write the equation of a circle is the radius. So I need to find out what the radius is, and this radius is 1, 2, 3, 4, 5. Okay, so radius is 5. I'm now ready to write the equation of a circle. And of course, you can definitely reference your formulas. So I don't point out to them, but I went ahead and wrote down your formulas for you, no matter what it is. So you can definitely reference that. I'm just going to say it. So writing this, it's always x minus something squared plus y minus something squared equals the radius squared, right? All right, so let's go ahead and put in the information that we have. So I'm given the center. So this is x and then y. So it's -5, so it's opposite. So this is going to be +5. And it's always opposite, right? So -5, +5. Opposite of -1 is +1. And this is the radius squared. So r squared is 5 squared, or 5 times 5, which is 25. So nice and simple, okay? All right, I'm going to teach both of these at the same time because these ones you need to know. Again, let me start off with what you're supposed to know. So this is what shape is this? It's an ellipse. This is a hyperbola. The only difference is this one is a plus, this one is a subtraction point. All right, so let me go ahead and write down what I should be looking for here. So in terms of an ellipse, I have something squared plus something else squared over something something. Now, A and B can interchange, but this is going to be X, this is going to be Y. But A and B can be different, okay? Now, when I have an ellipse, I'm going to have something squared minus something else squared equals 1. And this must always be a squared. And this must always be b squared. And I don't know why I didn't leave space to do my work, but I'll have to do it down here. All right, this must be a squared. This must be b squared, which means I don't know if this is x or y. In this one, this I don't know what it is. It could interchange, but this must always be x. This must always be y. All right, so really what it is I need to look for a and b and my center. Well, let's go ahead and put in the center in because the center is easy. So put it in the center in this question. X goes with -4, so this is going to be the opposite, is +4. Y goes with -1, the opposite is +1. All right, now, because I don't know where X and Y is, I cannot put the center in here, right? So here, I am going to actually have to first find if it's horizontal or vertical. So looking at it, it is horizontal, right? Opens to the left and to the right. All right, and if it's horizontal, remember, so, okay, let me write it down. Horizontal. You're looking at the negative. You think should go with the x, but it's opposite, so it goes with the y. And that tells us where to put stuff. So that negative must go with y, and that x must be that. Now I can put in my center. So x and then y. So this is opposite, -1, opposite, +4. All right, so I'm just left with a and b for both, right? So again, remember for an ellipse, a squared is always the longest one. So since this is stretched vertically, this is going to be my a squared. This distance here is my a, and then you square it. And that distance is 7 plus this 1 is 8. And again, feel free to count the boxes. I'm just not doing that. So that's my a is 8. And b is the distance from here to here. So that's 4. So b is 4. Now that I have my a and b, remember, if it's stretched vertically, it has to go a squared goes under the vertical, so under the y. If it's stretched horizontally, a squared would go under the x. In this case, because it's stretched vertical, a squared must go under here. So since a is 8, under here will be 64 because that's a squared term. And the other one, b, would be on the other side, which is 16. Okay, so that's the difference, the major difference between the ellipse and the hyperbola. All right, for the hyperbola, remember, it's no longer about longest or shortest, right? So it's just about understanding your labels. A is the distance from the center to the vertex. So this is horizontal, so that A is going to be horizontal. So this is A. So A equals 2 boxes. All right, this right here is B. B equals 3 boxes. So once again, it's not about the longest or the shortest, right? It's just about whether it's horizontal or vertical. And it's the distance from the center to the vertex. So now I'm going to put A squared has to go underneath the first one. So the first one is 2 squared, which is 4. And then b squared, which is 9, has to go underneath the other one, okay? And that's it, nice and simple. All right, finally, the parabola, if you got this one, you have, what information do I need? So I need to know if it's horizontal or vertical. So I need 3 things: direction, I need vertex, direction, every single time, vertex, direction, and I need p. So direction is down, right? If it's down, you're looking at the squared term has to be with what? The x. If it was left or right, the squared term would be with y. All right, but this one is up and down, so it's with squared. And p, again, I don't want to really say p is a negative, but what it is you just need to remember that in your equation you have a negative. P is the distance from, again, the directrix to the vertex, the directrix to the vertex, or the focus to the vertex. So this distance right here is p. And again, just reference the original picture. So that's 3. So p is 3. And really what we're saying is that directrix is somewhere here too. So 3. And it goes like that. Okay. So p is that same distance each time. This is p, that's p. The distance from, and I just keep teaching this, the distance through the focus to both of them is 2p, making a total of 4p. Okay, so just FYI. All right, so since we have all the information we need, let's go ahead and write it. What squared? X. So on this side, I'm going to have the x term squared equals. This is going to be a negative outside because of that negative. Some number, 4 times p, I guess I should just do it. 4 times p is 12. And then if I already used x, this is y. Boom. And all I'm going to put in is my vertex, all right? So my vertex is always opposite, or my center is always opposite. So opposite of positive is negative. Opposite of negative is positive. And you are done. Okay, so I know I'm taking my time on these explanations, but please just make sure that you just go through it. All right, next one. All right, find the center and radius of from an equation, nice and simple. From a circle. Remember, this is r squared, and this is your center. Just pull your center opposite. So opposite of negative will be positive. So this will be 12. Opposite of positive will be negative. So this will be -6. My radius is this is r squared. So to find it, you square root it. So radius is 15. Nice and easy. All right, next one. Find key features for ellipse from conic forms. Okay, so key features, I did 2 examples just to kind of show you with A being, the longest side being on the left, the longest side being on the right, just so that you're completely clear on when you have an ellipse, you're following A. When you have a hyperbola, you're following the negative, and A is always first, B is always second. So really making sure that you understand that difference. All right, so the question is going to ask one of these, okay? So I'm just going to do all of them so that we cover all of it. All right, perfect. All right, so let me get out key features. So this is an ellipse. Remember, a squared is longest is what I'm looking for, right? So I'm looking for the longest. Where's the longest? Right here. So that's a squared. So a is equal to 8, b is equal to 3, the square root, right? Find the longest. Longest is this one, so that's a. So a is equal to 5, and b is equal to 4. All right, so with an ellipse, you're looking for the longest side, and that gives you your a. All right, let's pull up my center. So center is opposite, so this is 3. Find x. This is 3, so find x. 3. This is y, and this is opposite, -2. All right. And again, in an ellipse, it always puts x first, so that's okay. So opposite, +3, opposite, +2. Nice and easy. All right. My vertices. All right, vertices. Again, you just need to be looking at pictures, okay, just in case you forget. So in an ellipse, okay, vertices is, if it's horizontal, the longest side is your vertices. Your shortest side is your co-vertices. So vertices is my longest side. So I really need to know, I'm going to be fooling around with this number 4, but it's a distance from here. So I need to just kind of think through. If not, you can sketch it just to be sure, but just kind of think through like, okay, what is changing and by what? So if I'm saying my longest side, which is 16, goes with x. So my x direction is going to change by 8 to get to my vertices. So I start on my center, so because this is a horizontal, right? I'll just give you a picture real quick. Okay, that's a horrible picture. But anyway, I'm saying here's my center, right? My vertex is going to be horizontal because it's a horizontal ellipse, right? So it's this distance here. I'm going to change my x of my center because here's my center. I'm going to move it to the left and to the right. Okay, so what I'm going to do is this. I'm going to write in my vertices. What's not going to change is my y. So this is going to be -2. Okay, but my x is going to change left and it's going to change right. So I'm going to take my x for 3. To get the number here on the left, I'm going to move 8 to the left of 3. So that's going to take me to -5. And you can do one of two things. You can count the boxes, or I don't know, you can do what? What can you do? Subtract them? But absolute value? Nope. Yeah, subtract them. So 3 minus 8. Yeah, so you can subtract them. All right, on this side to go to the right, I'm going to add. In fact, that's exactly what you do. I'm going to add 2 from the center. So here's the center, and I'm going to add the 8. So that's going to take me over to 11. Okay, so it's just really simple. You just need to visualize it. If you need to go ahead and graph it, go ahead and graph it just so that you can be on the same page. All right, so now we're going to do... well, I guess we're on a major axis. We know that that distance from here to here is 8. The major axis is the whole thing. And again, reference the picture if you need to. The whole thing, so the major axis is 16 because that's A and then another A. All right, co-vertices, we're going to do the same thing. We're going to just visualize it. So again, you start off at the center and you're going to go down to here and up to here. So what are you changing? You're changing your Y. So you're going to keep the center the same, but the Y is going to change, right? So X is the same. So this is 3. This is 3, but my y value is going to change. So -2 is going to change by going up, which is adding, and going down, which is subtracting, and that number is 3. So -2 plus 3 is going to give me +1, and -2 minus 3 is going to give me -5. All right, so that's going up and down. My minor axis is that distance from the co-vertices to each other. I know that half of that distance is 3, the other half is also 3, so that minor axis total is 6. Okay, so it's actually not bad once you kind of can visualize it. All right, then you need to go with your foci. And remember, your foci for an ellipse is a squared. Be very careful to remember this minus b squared. Okay, so if I'm looking for c, so therefore, c is equal to the square root of a squared minus b squared. That's what I'm really looking for, right? The foci. So do I know a? I sure do. So c is equal to the square root of a squared, which is 16. Oh, I did that wrong, y'all. Because the square root of 16 is 4, not 8. Yo, I'm tripping. All right, I'm tripping. I'm going to go ahead and correct that. My bad. All right, so it's not divided by 2, its square root, so a is 4. Okay, so a is 4. So I was going to change this left and right by 4, so I start here. X changes left by 4, so this is -1. I am so sorry. And right by 4, so this is going to be, starts at 3 plus 4 is 7. My major axis is 4 on this side, 4 on this side, so that's a total of 8. I do apologize for that mistake. The rest of it is okay. All right, I'm glad I caught that. So a squared is 16, right? 4 squared is 16, minus b squared, which is 9, so 3 squared is 9. So c is equal to 16, the square root of 16 minus 9, which is 5, which is approximately, and this is rounded to the nearest tenth, but I guess let me go ahead and teach it just in case. So you have 2.236 blah, blah, blah. So to the nearest tenth means one number after decimal. So this is my cutoff point. Then you look at this score right here. 5 and above, raise the score. 4 and below, keep it low. I don't know, keep it the same. All right, so this is approximately, C is approximately equal to 2.2 because the 3 doesn't do anything. All right, so we're going to repeat the process again here. And again, I do apologize for that mistake. I'll just make sure I'm really careful on this one. All right, so let me check it. Square root is 4, square root is 5. Okay, that part is fine. All right, so again, kind of start off with the sketch so that you understand what it is. Longest side is A, so it's stretched vertically. How do I know that? Because it goes with Y. So I'm going to kind of just draw like that. This is my center. The distance from my center to here is my vertice, right? So I'm changing what? My y. So what it means is because I'm changing my y, my x stays the same. So I'm going to write in my vertices. My x value is going to stay the same. Okay, so where's my center? Right here. So this is x. That stays the same. The only thing that's changing is my y value. And how is it changing? I'm going to add this distance here, which is a, and I'm going to subtract that same distance down. So starting here, which is 2, add 5, I'll get to here, which is 7. All right, starting here, which is 2, subtract 5, which will make me get over here, which is -3. And that's how you find your vertices and covertices. All right, so once you have your vertices, your major axis is the distance all the way through. And I'm not going to draw because I don't want this to get messy. So remember, this is already A, and this is another A, so a distance of 2A. So that would be 5 times 2, which is 10. Your covertices, once again, I'm going to go ahead and put in what's not going to change. So my covertices have to do with B, right? So B is this distance here. So again, you start at the center. I moved horizontally, so X is going to change, Y stays the same. So I'm going to put in my Y's just so I don't change them. And X is changing by what? 4. To the left, so I'm going to subtract 4. To the right, I'm going to add 4. So 3 minus 4 is -1. 3 plus 4 is 7. All right, my minor axis is the distance from the covertice to the covertices, all of this. So that's going to be B plus another B, or 2 B's, whichever way you're going to look at it, which is going to be 8. And then my foci, again, so we already wrote it down here. So I'm just going to write square root of A squared minus B squared. We're just going to put in the numbers. So A squared, so A is 5. So that's 25 minus B is 4. 4 squared is 16. That's still isn't that giving me the exact same thing I had? No, it doesn't. All right, so C is equal to 25 minus 16, which is the square root of 9. So C is equal to 3. All right, so looking at the hyperbola, remember A squared is always first, so this has to be A every single time. So this is A is 5, B is 7, so square root. The center for this, let me go ahead and just write it here. Find the X, so don't assume the first one is the X because in a hyperbola, it could go either way. So find the x, that's going to be that opposite is -6, y opposite is -1. That's my center. All right, so again, a is always first. So right here's whatever the example is. A is always first, so a is equal to 6, b is equal to 7. All right, so very different from an ellipse where a is the longest side, so you have to find the longest side, and that's a, but a is always first. Then the negative is going to tell you the direction, right? So the negative is with x, so this is a vertical hyperbola, so it looks like this. The negative here is with the y, so this is a horizontal hyperbola, so it looks like that. So look at this real careful. This one has y first, this one has x, this one has x, and then this one has y. So they're interchanged, right? So a and b stay the same, but x and y interchange. All right, so now if we're going to go and find, let me find the center of this one. The center is, so find x, so in this case, x is right here. Opposite is 5. Find y, opposite is -9. All right, so your vertices, remember, are from your center to your vertex, and you just got to reference the picture to see that. All right, so in a hyperbola, here's a hyperbola. Your center to your vertex is A. Your center to your vertex is A, always. Okay, so you do need to know that. Center to vertex is A. All right, so what that means is here's my center. The distance of A from my center will give me my vertice, right? So I need to know what direction it is. A is equal to 5, and it is attached to the y, which means I'm going to be going up and down a distance of A in order to get to my vertex from my center. So, for example, here's my center, here's my vertex, right? So I'm going to be going up and down. Which one is changing, x or y, if I'm going up and down? Y. So when I write down my answers, so when I have my two answers here, the one that's changing is y, x stays the same. So my vertices are still going to have the center of -6. But this y value is going to change by going up 5 and going down 5. All right, so you take your -1 y value, up 5 will give me 4, down 5 would give me -6. Okay, so very important that you know the direction. You got to sketch it to kind of see which direction you're going in so that you don't make a mistake. All right, now that I know that, I'm going to go find my co-vertices. So my co-vertices are obviously in the opposite direction this way, right? So here's my sketch. I'm moving left and right. So what's changing? My x. So when I write down my answers, my x is changing, my y stays the same. So my y is going to still be -1. But this -6 is going to change. I'm going to go left by what? Because this is my vertex. B is my co-vertex. So I'm going to go left by 7 and right by 7. So I take that number. Left, sorry, -6, right? Because it's x changing. Left 7, so -6 minus 7 is going to give me -13. And right 7, -6 plus 7 is going to give me +1. All right, so again, I'm going left and right. So once you picture it, it makes it very simple to kind of work through a problem. All right, so isotopes. Again, with the isotopes, you're going to get this right out the formula. You need to know that your isotope for you do need to know if it's vertical or horizontal. So this is vertical. So for vertical, the slope is going to be A over B. So your general equation is going to be y equals plus or minus A over B. And then you're going to have x minus h plus k. So this is your general formula. And once you have a general formula, you're just going to put it in. So I know my A is 5, my B is 7. So your answer is going to be y is equal to, now I can write this out as two equations, but I'm going to write it as one. So the first one is plus and the second one is minus. A is 5, B is 7, and then this is your center, right? So anytime you're inside a parenthesis opposite, so h is opposite, which is going to be plus, and k is just what it is. So this is just what it is, -1. So one equation is the plus version and another one is the minus. Okay, so this will be your isotopes. The equation of your isotope, sorry. All right, so to get your foci, remember this is different from a ellipse. An ellipse, you subtract them, right? In a hyperbola, you add them. So c squared is equal to a squared plus b squared, which taking the square root of both sides gives you c is equal to the square root of a squared plus b squared. Now you just put in what you need. So c is equal to the square root of a squared, which is this 25, plus b squared, 7 squared is 49. So that's going to give me 49, 69, 74. So square root of 74, which you're going to put in a calculator, is going to give you roughly 8.602. Round to the nearest tenth, so one number after the decimal. Then you look at the number after your cutoff point. 0 is not going to change anything, so C is equal to 8.6. If it's asking, then just so that, actually I didn't answer this question. If it's asking for, C, that's my C. But if it's asking for the actual vertices, then I do have to put them in, and I realized that I didn't do it on the other one. So if it is asking for the foci points, it's asking for these two parentheses, you need to know where your focus points are. So remember, your focus point is here and here. And so that means the center is the same, or your x is the same, and y is going to be changing. So I go back to my center. My center, x is the same, so -6. But y is going to change by what distance? Distance of now c, right? So the distance from here to here is c. So that distance. So -1 minus 8.6 and -1 plus 8.6. So -1 minus 8.6 is 7.6. -1 minus 8.6, I'm sorry, is -9.6. And -1 plus 8.6 is 7.6. And of course, just use a calculator. Okay, so I didn't work that out for here. Depends on what the question's asking. If they're just asking you to find C, that's C. If they're asking you to find the actual vertex, the coordinates, I'm sorry, for C, then you just add and subtract 2.2 to the center. All right. Doing this last question, I'll do it all the way through. I will be a little bit faster because at this point I've said the same thing twice. All right. So again, my vertices is center to your vertex and is A. So my vertices center to the vertex. So center to the vertex, center to the vertex. So this is left and right. So when I write this out, y does not change. So y is -9. X changes by my A plus and minus, right? So 5 minus 6 is 5 minus 6, -1. 5 plus 6 is 11. All right, now you do your co-vertices. So my co-vertices are here and here. So again, you have to do a sketch so you can see. Y is changing, X stays the same. So I'm going to write this down. Y is changing, X stays the same. X stays the same. Y is changing, plus or minus by my B, right? So -9 minus 7 is -16. -9 plus 7 is -2. Okay. Your isotopes are going to be, again, so for vertical, it's A over B. For horizontal, it's B over A. Okay, so we're just going to go ahead and put it in the general equation since I already have it here. So this is y equals plus or minus b, which is 7, over a, which is 6, and then x minus something plus k. So minus the center, x minus 5, it's opposite, and this one stays the same because it's a plus sign, -9. All right, your foci is C. Okay, so your foci is in the same direction here. So your parentheses, and I'm just going to put it down here. Your parentheses is changing in the x direction, so y is going to stay the same, so it's -9. And it's just going to be 5 plus or minus c, so I just need to find out what c is, and I'm just going to plug it right into the formula since I have it written down here. C is the square root of a squared, which is 36, plus b squared, which is 49. And that's going to give me 85. Which C is roughly equal to 9.219 to the nearest tenth. One number after decimal. Look at this number. 5 and above, raise the score. 4 and below, keep it the same. So this is equal to 9.2. And remember, we're changing x by plus and minus 9.2, right? X by, so the foci is right here. I'm at the center. This is the center. Minus C plus C. So 5 minus 9.2 is -4.2, and then 5 plus 9.2 is that 14? 14.2, comma -9. Okay. All right. So if you're asked to find the foci as coordinates, it's those two. If you're asked to find C, it's that one. Just depending on what the question was. Find the equation given certain things. So all these questions will be about find the equation given something else. So in this question, you're told it opens down. It has a focus and a focal diameter. So 3 things you always need to know.
direction, vertex, P. So let's start off with direction. So they tell us it's opening down, it's vertical and down. All right, let's go ahead and pull out the vertex, HK. So how do I pull out the vertex? Well, I'm given the focus, which is right there, is -1, -2. You're given the focal diameter. So let's go over what focal diameter is again. So that's 32. So going back in our notes, on the very first page when we went over this, the focal diameter is 2p on each side, 2p and then 2p. So the total is 4p. Okay, so 4p is your focal diameter. So I know my 4p is 32. So 4p is 32. Divide both sides by 4, you're going to get p is equal to 8. So I know my focus, and I know my p, and I need to find my vertex. So I'm going to go up to my vertex p units. In what direction? Y. So the only thing that's going to change is y. X is going to stay the same. And how is it going to change? By 8. So you're going to add 8 to go up to the vertex. So you're going to get -1 and 6. All right, once you have that information, you can write down the equation of the parabola. So you know it's x squared because you know it's vertical. So it's x minus your center, which is 1, squared, your 4p, which is 32, y minus 6. And since you know it's opening down, that 32 has to be negative. Okay, since it's opening down, it has to be negative. All right, so you've now written your equation. And I'm just going to highlight that because you're not going to forget that, okay? So please make sure you keep that in mind, okay? You do need to know whether it's up or down. All right, so again, you're writing an equation, 3 things you need. Direction, vertex, P. Okay, so is this vertical or is it horizontal? Well, let's go ahead and rough draw it. So 10, 5 is about there. The directrix is at y is equal to -9, which is right there. So if that's the directrix and the focus is there, the parabola has to be something like that, which means it's vertical and up. So in this case, vertical is going to mean your x squared. Up is going to mean p is positive. So second thing is we need to get the vertex. Okay, so what do we know? We know the focus is 10, 5. And we know that directrix happens at y equals -9. And if we pick a point right underneath it, that's going to be the point 10, -9. So the vertex is going to be in the middle of those 2 points. So we're going to find the midpoint of those 2 points. Midpoint, what do? Add them together and divide by 2. So that's going to give me 10. And 5 plus that is -4 divided by 2 is -2. So I've now got the vertex, right? I need to find P. P is the distance from either the directrix to the vertex or the vertex to the foci. So what's changing? So let me start at the directrix. I'm starting at -9, right? I'm going to go up P units. So what's changing? Is X or Y changing? Y is the one changing. So Y is going to change by P and end up at the vertex of -2. So it's going from -9 to -2. So what is P? From -9 to -2. It's going to be 7 because -9 plus 7 is -2. So P is 7. Once you have that, you can write the equation. So X is squared. 4 times P is 28. And then you have Y minus. And now just pull the vertex. So that's -10 plus 2. This is a listening check. Color in the y plus 2 part. Color in the y plus 2 part. All right, let's take a look at another one. Again, 3 things every single time. Direction, vertex, P. Okay, so you're given vertex already. That's cool. Is this up or down? Well, let's sketch it to look. So -3, 7, about there. 1, 7, about there. So if the vertex is there, the focus is that, it has to open to the right, which means the directrix is on the other side. So it opens to the right, which means P is positive and it's y squared. So P is positive and it's y squared. All right, so what's the vertex? Did they give it to you? What's P? The distance from the vertex to the focus. That's P, right? So that distance. So you can either count in the x direction or you can use the distance formula. All right, I'm going to count from -3 to 1 is 4. So I start at -3 in the x, I go to focus, which is 1. It's a distance of 4. So P is equal to 4. Once I have that, I can put in my equation. Y is squared, so it's going to be y minus squared equals 4 times P, which is 16, x minus whatever it is. So the vertex is +3 and -7.
Find key features of a parabola. All right, so this tells you that it's a parabola. I also know it's a parabola because it has only one squared. Find key features. So here are the key features that you can find. 3 things that you can always pull out from an equation is this vertex. So my vertex is going to be vertex x, opposite, -3, y, opposite, which is +9. My direction, so because x is squared, it is either up or down. Because this is negative, it is down, so that's my direction. And then what else do I need? I need P. P is equal to, so remember this is 4 times P, so 28 actually divided by 4, 6. All right, so direction is down. And again, this is just so that you can use this to find whatever you need to do. You just need to know what that is. Your vertex is right here. So your vertex is -3, 9. Your axis of symmetry, so axis of symmetry is going up and down. If I extend this line, is it going to cross the x-axis or the y-axis? And hopefully you're saying the x-axis because it's going to go up. So I'll prove it to you. If this is -3, 9, so it's like something like this. And I won't draw this again. I just want this to be a rough idea. So here's your y-axis, here's your x-axis, right? This line right here, if I extend it, you see crosses your x. That means it's x equals. If it crossed your y, it'll be y equals. All right, so x equals, and where does it cross? It crosses in the same place as the vertex, so -3. All right, what is your focus? Okay, so once you know that, you need to know P, right? So your focus right here is P, so this distance is P. What's changing? Y. So I'm only going to look at the Y, and I'm going to go down P so I can get to my focus. So down P is going to be 9 minus 6, which is going to give me 3 on the Y, and X stays the same. All right, directrix, remember, is above, so that's going to be up here. All right, so again, if I apologize for this being unneat. If I draw the line, what does it cross? It crosses the y-axis, so this is y equals. And where does it cross the y-axis is the question that we're asking. It's P away from the vertex. So if I go up P, I'll get the number that's right there, right? So this is y that's changing, so I only care about this. And I'm going to go up P, which is 6. So 9 plus 6 is 15. All right, real simple. All right, I'm going to go over another question. So this time, instead of it being open up or down, it's going to be open right or left. And how do I know that? Because y is squared, so it's going to look like this or like this. Okay, once again, because it's negative, it's definitely like this, right? Opens to the left. All right, grab your vertex. So again, I'll draw my direction, and I'll draw my direction. Let me grab my vertex first. X, so find X. Don't assume X is first, right? Find X, opposite is -5. Y is opposite -2. So I have something like this. And this is just a sketch because, again, I just want to, oh, I did it on the wrong place, but whatever. Doesn't matter. All right, so boom and boom, right? I'm just going to use this as a reference, and that's why I'm doing that. All right, so that's the direction left. Axis of symmetry, again, where does this line go through? It's going to hit what? Y. So this is going to be Y equals, and it's going to hit it where? P distance. I'm sorry. Axis of symmetry, this place right here is the same y value as my vertex, right? So my y value is -2. That's easy. So it's there. All right, my focus is going to be in here, and this distance is what? P, right? This distance is P. So I'm going to change X. So here's my vertex. Y does not change, so -2 does not change, and X changes left by P. And what is P here? P is equal to 28 divided by 4, which is 6. So I'm going to go left 6. So -5 minus 6 is -11. My directrix is to the right, a same distance as the focus, but in the opposite direction is P. So I'm changing X again, okay? And again, when this is my directrix, it's going to go up and down. What does it go through, X or Y? It goes through the X-axis. So it's X equals, and that number for X is the same number, is P away from this one, right? Because I'm going right here. So find my vertex, X direction, because it's changing X. So I'm going to do -5 to the right? So plus 6. -5 plus 6, so X is equal to 1. So you do need to know that your axis of symmetry and directrix are going to be opposite letters, okay? So they're going to be opposite each time. Write an equation of a circle from key. Oh, that's easy. Equation of circle is really easy. Determine the equation with a radius of 5 center of that. So again, you just need to know the general form of an equation of a circle is x something squared plus y something squared equals r squared, right? And they give you the center, so opposite of -5 is +5, opposite of 3 is -3. And this has to be the radius squared, so 5 squared is 25. Right. Write the equation of ellipse from key features. All right, so determine the equation of ellipse with this center with the vertex and the co-vertex. Listen, everything is about you knowing the like what it looks like, being able to visualize it. So you're going to start off with, let me know what I'm supposed to get to. So this is an ellipse. So an ellipse is supposed to be something squared, and an ellipse is plus, right? Something squared, and it's always x first and then y equals 1 over, and with an ellipse, the longest side is a, right? So, but I don't know where the longest side goes right now, right? But that's the longest side. So once you have it set up like this, you're just trying to find out what HK is, A and B is. All right, so let's go ahead and draw what they give us. So again, you just want to kind of visualize this. So I want to send off -5, 3, so it's in like quadrant 2. So let me do something like this. And again, this is just an estimation, -5, 3. So say about that. I'm just going to label that this is my center just so I don't get confused. -10, 3, -10, 3. That's my vertex. All right, and this is an ellipse, right? So it does something like this, right? So, and then co-vertex is a -5, -5, 6. So over here is my co. All right, so that makes sense because now that tells me it's a horizontal. Well, actually, I don't know if it's horizontal because I don't know if I graphed this correctly. So let me find this distances actually. So this is -5, 3. Vertex is -10, 3. So how far is this, right? So you'll notice the y does not change, but the x changes. How does it change? It changes by 5. So this is 5, right? We're going to do the same thing with the co-vertex. So this is -5, 6. And again, you can use the distance formula to calculate that, or you could just draw it and see it. All right, so again, with the center and the co-vertice, what changes? -5 didn't, x isn't changing, y is changing, right? Because I expect it to go up and down. So it goes from 3 to 6, so that's what, 3, right? 3 plus 3 is 6. And here, x-wise, I'm -5 minus 5, because I'm going to the left, is -10. All right, so it just so happens that A, all right, because A can be on either this side or this side. I just need to know with what letter does it go with. It's the longest side. This is the longest side, and it goes with X because this is horizontal. So I'm going to put A right here, which is going to be A squared, which is 25. I'm going to put B right here. So this is 3, so squared is 9. And then now my center, I'm just going to grab it opposite. First one is X, so that's going to be opposite is +5. Opposite of 3 is -3. And what is it saying? Just determine the equation. So that's all I needed to do. So sketch it so that you can see it, so that you can write the equation. I'll do another one. Determine the equation of an ellipse. Now I'm given different things. Again, it doesn't matter what you're given. It's an ellipse. Start with what am I trying to end up with. So I know for an ellipse, X is first, Y is second, and A and B depends on which one is the longest side, and I have to grab that from the information. So I'm going to graph, and again, this is just a sketch, so it doesn't really matter if your sketch is kind of off. You know, you're just using it for a reference, right? So this is 2, 12, 2, 2. So these are mostly positive, so I'm going to think it's on quadrant 1, so I'm just going to draw it like something like this. And again, if I'm off, I'm okay. It's not a big deal. All right, so 2, 12. So 2, 12. So I'm going to label this F for foci. Let me say F1 maybe. And then 2, 2, so 2, 2, foci 2. All right, and I'm just going to put this in because I realize I do need the numbers 2, 2. All right, then the co-vertices are 14. So this was around 2, so 14 somewhere here. I don't know. It doesn't matter. 7. 7 is somewhere here. So this is V1. All right, and then this is 14, 7. And this one is -10, 7. So -10 on this side, 7 on this side. So this is co-vertice 2, and it is -10, 7. Now that I have a picture, right, so I know this is an ellipse. So an ellipse is not going to go through the foci like here, but it's going to be up here somewhere because those are going to be your vertices on the same line as your foci. All right, but the big thing is, of course, I need the center. So there's a number over here that exists that's the center, right? And how would I find that number? So I've got two choices. It's in the middle of these two foci, or it's in the middle of these two co-vertices. Does not matter what you choose to do. It's up to you. Okay, so I can see if I do up and down, it's changing from 2 to 12, so it's changing by 10. So it's really going to be 5 each piece. So 12 minus 5, or 2 plus 5, so it's already 7. So it's 2, 7. Now, if that confused you, again, that's okay. This is the midpoint of these 2 points. So how do I find midpoint? Midpoint, what do I do? Add them together and divide by 2. Add them together and divide by 2. So that's going to give me 2 plus 2 is 4, divided by 2 is 2. 12 plus 2 is 14, divided by 2 is 7. And look at that, I still get that. Okay, so if you want to do the math, by all means, go ahead and do the math. Now, since I've gone ahead and gotten that, I have the center. I also need A and B. Remember, in an ellipse, A is the longest side, and it's to your vertices. So from here, the distance from here to here, that's what I'm looking for is A. So I'm changing in the Y direction from 7 to, I don't know what that point is. So let's pause on that. Let's find B. So I'm going from here to my co-vertice. This is B, right? That is definitely B. All right, so from here to here is B. And now I'm changing X. So I'm going from 2 to negative 10. So that's 12 total. Or you can go to the right and stay positive. From 2 to positive 14, that's still 12. So my B is 12, so that's cool. I now know my B. My A is going to be longer than my B. So my B is horizontal, so this is my B right here with X. So B squared is 144. I don't know A, but I know C, because C is the distance from here to here, right? My center to my foci. So from 7 to 12. Or had I already found? No, I didn't. From 7 to 12, so 12 minus 7 is 3, 5. So my C is 5. But I do know a formula that tells me, that has a relationship in an ellipse, right? So it says C squared is equal to A squared minus B squared. In other words, C is equal to the square root of A squared minus B squared. So I have A squared and B squared, so I have C. So I don't need to do that, I'm sorry. I have C and I have C and B. So I'm looking for A. So I'm going to take this to the other side. It's going to become plus. So I've got A squared equals C squared plus B squared, which means A is equal to the square root of C squared plus B squared. So you just have to put the numbers in. So C squared is 25, B squared is 144. So 25 plus 144 is 169. Take the square root of that, that's going to give me 13. So A is 13, so this blue arrow right here is 13. All right, now I have what I need, and that's in the Y direction, right? So 13 squared is 169, and I now have my center anyway, so pull it and match up X and Y. So opposite is negative 2, opposite is negative 7. Okay, so that one was a little bit more entailed because I have C, not A and B, but the process is still exactly the same. All right, determine the equation of a hyperbola. So again, you need to know how you're ending, right? So a hyperbola is very important that you have a minus. And the other thing is you always know A squared is first and B squared is second. Okay, so once you know that, this is my end piece. So I need center, A and B in order to write it. So again, what am I given in my question, right? So I'm given vertices, so go ahead, and vertices are always A, right? So go ahead and graph it. So this looks like one's positive, one's negative, so maybe about half-half. And again, it's just an estimation, it's just to give me a sketch. So 0, 7 is right here. 0, negative 7 is right here. So this is 0, 7, 0, negative 7. And these are my vertices, vertex 1, vertex 2 maybe. Vertices that I'm given isotopes. So right now I can't really use my isotopes because isotopes are A and B, but I need to know at least one in order to calculate it. All right, so cool. Let me find my center because I need my center. So my center is in the middle. I already know it's right here, but if you can't visually see that, right, that I'm changing from negative 7 to positive 7, so that's a distance of 14, half of which is 7. So if I come down 7, I'll be right at 0. So this is 0, 0. But mathematically, if you want to do it, midpoint, what do? Add them together and divide by 2. So 0 plus 0 divided by 2, and 7 plus negative 7 divided by 2. It's going to give me 0 plus 0, 0 divided by 2 is 0. 7 plus negative 7 is 0 divided by 2 is also 0. And again, you end up at the same place. Or you can kind of work through how to get half from just the Y. All right, so I know my center, okay? So I don't know which one comes first, X or Y, so I can't put anything there until I know if it's horizontal or vertical. But this is definitely vertical because the distance from your center to your vertice is A, which means it has to be going up and down like this. All right, so your distance from your center to your vertice, very important that you remember that, is actually A. So that makes it a vertical one. If it's vertical, okay, it means your negative goes with the opposite. It goes with x, and this is your y. Okay, so let me say that again. If it's vertical, your negative goes with the opposite. So this is x, and that is y. All right, so now that you know that, you can put in your centers that you just found, which was 0, 0. So, and again, x first. So this is minus 0. Y second, minus 0. So this one's going to simplify. That's okay. I'll simplify it in a second. All right, so I need to find A and B. A is the distance from my center to my vertex. This is A. Right here. So A is equal from 0 to 7 is 7. 7 squared is 49. B is the distance from here to here. But how do I find that? All right, so let's see what else they give me. So they give me my isotopes, which is 7 over 4. Because this is a vertical hyperbola, so vertical hyperbola, so for vertical, your slope is A over B. So you do need to remember that, right? So your slope is A over B, and we know that my slope being A over B is 7 over 4 for both, right? All right, I do know A is equal to 7, so I can replace that A with 7. So I have 7 over B equals 7 over 4. And just depending on how strong your math is, you can do several things here, but I guess the easiest thing you might have heard before is cross, multiply, and divide. So 7 times 4, and I'm not actually going to multiply them out because you'll see why in a second. B times 7, or 7 times B. Divide, so cross, multiply, and divide. So divide by 7 to isolate B, divide by 7 to isolate B. These 7s cross out, the 7s cross out, so B is 4. Which, if you kind of worked it out, you would do 7 times 4 is 28, and then you get 7b divided by 7. 28 divided by 7 is still 4. So the same kind of difference. Now I got my b, so I just put it right there. So 4 squared is 16. You're not going to be able to write this in, so you do have to simplify this. Y minus 0 is the same thing as saying y squared minus x minus 0 squared is the same thing as saying x squared over 49 over 16 equals 1.